Hey everybody. So quick one here, I want to talk about random modulation sources. You might already know about the kind of classic design of the sample and held noise, which has been around for a long time, kind of a Buchla thing, which is a great way to be able to get a stream of random numbers when you need them to do something, modulate something. And what I want to talk about today is how we can get this sample and held noise signal to be smoother. So we still use the same stream of random values, but rather than using this stair-step shape to just jump from one to the next, we actually ramp smoothly from each one to the next. Now there's one pretty simple way to do this, which is just to use rampsmooth, which is exactly what it says on the tin. It is a signal smoother that uses ramps, and it takes two arguments, which are just the time over which to ramp from one value to the next in samples. So if I stick this in here, you could see that we smoothed it out. But this is not the end of the video, because there's one sort of issue with this, which is this ramp time needs to be synced up with the time, the interval between which I'm requesting new values, right? So in this case here, I'm using a phasor and a watt object to produce a stream of pulses. And for this ramp smooth to really ramp, like if I shorten this, let's say, if I make this 2000, 2000, let's see what happens. Yeah, you could see we ramp and then we stay for a while. What I want is for us to like ramp to the value and then immediately start ramping to the next one so that the length of the ramp is exactly the same as the ramp of the phasor. Which then begs the question, well, why don't we just use the phasor then to do the ramping? So that's what we're going to do. So Gen is definitely, I think, the easiest way to do this. And I'll explain why in a little bit. It's because we need a history, we need a feedback, and I'll explain how that works. So we'll give this a name, interp_saw, and we'll take the noise and the phasor. Inside, we'll use comments, signal to sample, clock phasor. Cool. And we'll use a delta and a less than 0 to turn the phasor into a stream of pulses. So this is our airsats what. If you have a signal that looks different from a conventional phasor, you might need to use a different version of this, and you can look at generating sound and organizing time for examples of how to do that. I find that like I almost never pass in something that doesn't kind of meet the minimum conditions that are required for this to function predictably, so I just use this. But if you got some crazy clock signals that have negative slopes in them, this isn't going to work, and you would need to use something different. We can then use latch, which there is a saw in Gen. It's slightly different. I just use latch. And this right here will exactly replicate what we have on the left side of this patch. So same thing, assuming a phasor that's conventional. And so now time for the fun part, which is the actual interpolation bit. So I'm going to use the mix object, which is just a crossfader like you'd find on a DJ mixer, where the first inlet is the left side of the crossfader, the signal at the left side. The middle input is the signal at the right side of the crossfader, and then the rightmost inlet is the fader itself. So we're going to use the phasor value as the invisible hand that moves the fader, and then we will send the newly latched sample and held noise value into the right inlet. And then we need to sample the old value. And the way that we're going to do that, and the reason that we're using Gen here, is because easiest way to do this is to basically, at the point at which we get a new value, we just sample and hold the output of the mix here. Because we know that when we get a new value, we ramp to it. And then when we get a new value, then the previous new value becomes the old one. We hold on to that, and we want to pass that into this first inlet. Before we do that, we look at the phasor. We can see that what we're doing is we're actually just every time we get a new value, we ramp to that value over the phase of the phasor from 0. So we just jump to 0 and ramp to it, jump to 0 and then ramp to the new value. And that's what you're seeing here. And that's because we don't have anything patched in here. But if we take the history, which is the value from the last sample frame within Gen, because the thing to always remember when you're working in Gen is that this is a patch that is executed at your computer's sample rate. So 44,100 times a second, this patch gets executed. And computers work with discrete time, and it's not going to be able to have a value that it passes from its outlet here, this object's outlet, that it can also use at the inlet, because that just doesn't make any sense to the computer. In an analog system, that kind of stuff is possible, but in a digital one, it isn't, because time is sliced up into discrete slices. So that's why we use history. What history basically does is it says, can you use the value from the last time that you executed this gen patch, which was 1/44,100th a second ago, assuming your computer sample rate is 44.1 kilohertz. So we're going to take that output from the last sample frame, and we will latch that. And we'll use the same impulse in order to do the latching. And you can see that gives us this really nice triangular version of the noise signal. Now, the last detail that I would like to add here is, what if we don't want it to be so triangular and pointy? Well, this is where some unit shaping can be useful. And for this, I'm going to use the ease package, which is, I don't think, installed by default in Mac. So if you try to add this and it doesn't work, you need the ease package, which is in the package manager. And what this object does is it takes a phasor and it shapes the range. So if I pass the phasor through it and I add an adder UI that lets me update the function, in its default state it doesn't do anything. But if I switch to one of these other shapes, like in cubic, you can see that we get this nice exponential shape. If I do out cubic, I'm going to use the same function, but it will give me the logarithmic version. I could also use in out cubic and get kind of a nice S shape, or in out quadratic, let's say, which will give us the same thing, but just a little bit less extreme. And if we take this type of signal and use it to perform the interpolation and the sampling and holding, then that will give us a really beautifully smoothed out version of the noise signal. And the reason basically is just because we modulate the slope of the crossfader so that we kind of ease out of the old value and creep up, easing in on the new value, rather than just, coming in and out at the same rate and giving that sharp point in the signal. And this is just a beautiful line to watch, I think. It's just, there's something, very organic about it. It's like watching a stream or something, like watching water flowing. I could just sit here and watch this. So the last thing I want to talk about is having to do with the idea of kind of our, we could say our workflow. which is if I make this really great interp saw gen patch, I want to be able to reuse this. I want to be able to have it again in the future. And in my ideal world, I would really love to be able to go like this, interp saw, and actually have it like be an object. Now, how did I do this? This is not a Max object. If you're watching this video right now and you go into Max and you try to create this interp saw, like that isn't a thing. That doesn't exist. Basically, I made a Max object. And you may think I used Rainbow, which you could do. You can use Rainbow to make Max externals, but there's actually an even easier way where we don't have to use Rainbow at all. We can just use our gen patch. And the way is this thing called define. So Max has this feature. Let me go to the reference. Define message. The define message of the Max object lets you declare an object that loads a file of code for one of Max's powerful supported language-based objects, JavaScript, Gen, and jit.gl.slab. So basically what this means is, if I have some code in JavaScript, in Gen, or jit.gl.slab, which is like a shader, then I can basically tell Max to treat that as though it's a Max object, and then it really behaves like a Max object. And in this particular case, we don't have any parameters in this gen patch, so there's nothing to get. But if this had parameters, it's really handy. You can really just use it like it's a normal Max object. And the way to get it to actually do this is you basically send a message to Max that says define, and you're going to tell it to define. You're telling it, it's like a dictionary. You're saying interp saw is defined as gen interp saw, and this is assuming that we have saved this patch. So if I say, and I already did, by the way, separately. So if I say gen interp saw, this is, I'm loading a file called interpsaw.gen.dsp, right? If you wanted to be a little bit pedantic, we could do that, gen.dsp. And so you're telling Max, like, if I say this, under the covers, this is what I want. And I can send that message to Max, and it'll do that. You can also tell Max to send this message to itself every time Max loads, which is how we make it so that when I start up Max in the future, if I close Max and start it up again, this kind of a relationship gets linked. Because if I were to not do that and just send the message from the patcher here and then close Max and reopen it, I would have to fire off this message again in order to kind of create this relationship between this alias and the actual patch that underlies it. So the way that we do that is with a package. So I'm going to go to my text editor here, and the Philip Meyer Max Tutorials repository on GitHub is a Max package. If you're not familiar with Max packages, I've been talking about them more and more lately in videos. But basically, the idea is a collection of patches, of externals, of gen patches, any kind of Max content that goes together and that you want to be able to reuse. So there's usually some sort of thematic relationship between the items in a package. And the idea is like, I want to basically create a little module of related things that all work together and that are all immediately available to me whenever I'm Max patching. So I think this is a really good thing to create for yourself. Like, I have kind of many of my own personal packages, because as I start to develop ideas, I want to be able to basically reuse those components. And so if I have a new idea that's kind of a new concept for something that I'm working on, I'll make a new package for that. Rhythm and Time Toolkit as an example, but it doesn't have to be as elaborate as Rhythm and Time Toolkit, where everything's an external that you made with Rainbow and so on and so forth. You could just have like a collection of your own Max abstractions be stored in a package, and that just makes it very easy for you to keep those patches organized and to make them reusable. You can also have like reference docs for them. You can have help patches, so you can really kind of treat your own library of patches like Max treats its library of patches and externals. And I think that this is one of the reasons that Max is so rewarding to us as artists, is that over the time that we use Max in our lifetime as Max programmers, we accumulate these collection of tools that we built. So in addition to accumulating knowledge and skills and getting better and better at patching, you also kind of congeal that knowledge and skill into tools that you made that you continue to own. And in this way, Max has pretty interesting relationships, I think, to a lot of physical crafts where tool making is kind of part of the craft. Mark Fell's book talks about this, where he's talking about steel workers. All over YouTube, you find all of these creators in the physical domain, like, I don't know, Adam Savage from Mythbusters, who's got a great YouTube channel where he makes stuff where, like, he's got this workshop full of stuff that are materials and tools that he made that allow him to make what he wants more easily. And I think Max is kind of unique among software in that it lets you do that, right? If you are like a person who uses Adobe Photoshop or After Effects or one of these Adobe things, you just don't get that same dynamic. You can't make a tool for yourself in one of those things and then expect to be able to use it in 10 years because they don't really want you to be able to use it in 10 years, basically. Those things become obsolete for commercial reasons that those companies have. Cycling, on the other hand, has been committed to backwards compatibility for like since the early 90s, and you can literally open patches from 1992 in Max 9 and they work. I did a project recently, which I'm really excited to share at some undefined point in the future, in which I worked on a patch from 2005. And there was some creaky old school style patching in there, but it 100% worked. And I kind of modernized it. So yeah, I just think that that's a really beautiful part of, of this particular tool. And this is sort of core to my pitch now on like why Max, right? People will say, okay, well, tell me why I should learn Max. And the caveat, of course, is if you want to make lots of music very quickly, then this is certainly not the way. But if you want to be able to build a practice as an artist or as a creator that lasts many years and that continually rewards you, and that rewards you more and more the more that you commit to it, then Max is really beautiful for this particular reason. So after that aside, I'm going to show you how to do this kind of define thing. So inside of my package, in the init folder, I'm going to create a file called init.txt. And this is, you can just use this same file for all of the objects that you want to define. The init.txt, it's basically just a list of commands that Max is going to execute on startup. And we'll just write that message without the semicolon. So maxintile interp gen interp .gen.dsp. And let me just make sure that that matched up with what I have. In fact, I could just copy this. Probably a better idea. There we go. And that's that. So now when I load Max, because I have this here, this will just happen when Max loads, and this object will be available to me. And now it will be available to you if you have this package installed. Which, by the way, if you typically get these patches by downloading the patch itself, that's fine. But another thing that you can do is clone the repository and put the cloned repository in your packages folder in your Max library. And then that basically means that you can keep this folder in sync with what's on GitHub. So when I add new videos and add new patches, this will just stay in sync. And then all of these other features that come along with the package, like this init, are available. And while I'm at it, I'm actually going to do one other one, which is max define phasor scope. Live.scope at range negative 0.1, 1.1. Because you've seen me so many times in these videos type live.scope tilde at range negative 0.1 to 1.1 to get a scope on the range of 0 to 1. You can also do this. So not only do you have to use gen and JS, but you can actually define objects and with specific arguments as their own quote unquote objects. So if I go back to Max, I'm going to copy this because this only gets executed on startup. So I'm just going to I'll trigger it manually. So I'll do this, and then I say phasor scope. Boom. And actually, this signal's on the range of negative 1 to 1, so that isn't what we want that for, but there you go. So, yay, okay. That was, I talked about more than I expected to in this video, but a lot of cool stuff there. If you have any questions, let me know down below. If you have an idea for how to do this in MSP, I'm always curious about different ways of doing stuff, but I think this gen approach is pretty nice. That's it. Thanks. See you next time. Bye-bye.